A student carries out a reaction between lumps of calcium carbonate and hydrochloric acid. Then we've got the equation. So the calcium carbonate is reacting with hydrochloric acid to form calcium chloride, carbon dioxide gas, and water. A. Which of the following changes would decrease the rate of reaction? So let's look at the options, and we need to tick just one of the boxes. So reduce the temperature of the reaction by 20 degrees Celsius. If we decrease the temperature, then the particles will be moving more quickly. They're going to collide less often. And when they do collide, less of the collisions will have the activation energy. So we would expect that to decrease the rate of reaction. So that's looking like quite a good answer. But let's check out the others and see what other options are there. So the second option was to increase the concentration of the hydrochloric acid. If we increase the concentration of the hydrochloric acid, there's going to be more acid particles in the same volume. So if there's more acid particles there, we could expect them to collide more often and the rate of reaction to increase rather than decrease. So that doesn't look like the answer that we're after. The third option, doubling the concentration of the hydrochloric acid, was quite similar to the second one. Doubling the concentration of the hydrochloric acid, there's twice as many acid particles in the same volume. So we would expect them to collide twice as often. So the rate of reaction would increase rather than decrease. So again, we can remove that as a possible answer. And the fourth option, increasing the temperature of the reaction by 5 degrees Celsius. If we increase the temperature, the particle is going to be moving faster. They're going to collide more often. And when they do collide, more of the collisions will have the activation energy and therefore be successful. So increasing the temperature, we would expect to increase rather than decrease the rate of reaction. So our first option, reduce the temperature of the reaction by 20 degrees Celsius, would be the only one which would decrease the rate of reaction. B, the student finds that 40 centimetre cubed of carbon dioxide gas was produced in 120 seconds. What's the mean rate of reaction? So obviously the reaction will happen more quickly at the beginning when the reactants are there in higher concentrations, and as they get used up, then the rate of reaction would decrease, but thereafter just the mean rate of reaction. So let's look at the amount of carbon dioxide produced, so that's 40, and then the amount of time was 120. So notice, although we usually do a big number divided by a little number when we're learning to do divide sums in maths, in this case, it's actually the smaller number, 40, divided by 120. So that's going to come out as 0.3 recurring. So we can rule out two of the answers immediately. What they've done there is to put the numbers the wrong way round. So now we need to look at the units to work out our final answer. So our unit, we've got centimetre cubed divided by seconds. So if we look at the two options that are remaining, this one at the bottom is the right number, but the units are the wrong way round. So we can remove that one. So our final answer is going to be 0.3 to one significant figure, centimetre cubed per second.